This video is on the objective, understand and interpret the test statistic and p-value. And this is number 2, so not going to do as much explaining as I did in the first video. Go back and watch that one if you want some more explanations. I'm just going to work through the problem, show you how to work a problem related to this objective in your Newton Alta homework. Okay, so you're Karen, a medical researcher, is studying ways to lower blood pressure in patients. She would like to test the claim that reducing sodium in a patient's diet can lower blood pressure by more than 9, whatever this is, mercury millimeters on average. So if the z test statistic was calculated as z equals 1.05, so remember this is you take a sample, and here we're talking about means, averages, right? You would take the sample mean and then find the z-score of that sample mean in the distribution of the sample means, right? The distribution of x bars. But we're not getting into all that. They gave it to us here, right? The test statistic is 1.05. We're eventually going to see a video where we have to calculate this ourselves. Now the question is, does the medical researcher have enough evidence to reject the null hypothesis and assume that alpha is 2.5% here? Alpha is 0.025. Alright, so here what's the claim? Right, the claim is that the average reduction of this blood pressure is by more than 9 mercury millimeters, whatever this is. So mu is greater than 9. This is a right-tailed test, right? Because the mu is greater than 9, right? That would be the alternative hypothesis. So the rejection region, this purple region is the rejection region. And they're saying alpha, the significance level is 0.025, 2.5%. So they've moved this z-score down here to a place where the area to the right is 2.5%. That's the purple area. Now our test statistic, right, for our particular sample was 1.05. Right. So move this to 1.05. So definitely the test statistic, my sample, come on. So the sample has definitely not entered the rejection region. You can also tell that from the p-value, right? The red area, the area to the right in a right-tailed test, the area to the right of your test statistic is called the p-value, and the p-value is greater than alpha. If that happens, if the p-value is greater than alpha, you're not in the rejection region. You don't reject the null hypothesis. Now the null hypothesis here would be that the average equals 9. Remember, the null hypothesis involves equality, and the alternative hypothesis does not. So we'd keep that. We would not reject the null hypothesis based on this sample, based on this evidence. Now the alternate hypothesis was that it's more than 9. So I'm looking at these ones that are more than 9. See, there is enough evidence to suggest that reducing sodium can lower blood pressure by more than 9. No. Because if we're not rejecting the null, we're not accepting the alternative, and this is accepting the alternative, so there's not enough evidence to accept the alternative. That's this fourth option. Okay, if you don't reject the null, that means you're accepting it, and if you're accepting the null, then you're not accepting the alternative. I hope that makes sense. And if you reject the null, that means you're accepting the alternative. All right, so we would have answered that third one if we rejected the null, if my test statistic ended up in the rejection region, or if the p-value was less than or equal to alpha. I would have rejected the null, and then we would have accepted the alternative. And again, please read through your answer explanations, especially if you got it wrong. Probably try to pick up on where you went wrong, and try to do better the next time. Alright, so hopefully watching this helped you a little bit. Watching my first one probably helped a little more because I did more explaining and writing. But hopefully these couple videos together help you with questions related to this objective. And thank you very much for watching.